Hey everyone, it's Mr. Swank. Happy Friday and happy May because, well, it's Friday, May 1st. And we are doing another Chemistry 1 lesson today. And today we are talking about what is scientific notation. And it's time for the best part of the day. So here's your joke of the day. Why do fish form schools but ants form colonies? It's because true ants don't go to school. True ants? Truants? Anyway, let's talk about our objective today. So our objective is we're going to define scientific notation. Now, this is a really important concept into measuring in chemistry, so let's get into it. We're still talking about quantitative measurements. Remember, quantitative measurements talk about numerical measurements, how much there are. And we're talking about big and small. Why? Well, what happens when we have a ridiculously big number? For example, that. You want to take a minute and count all those zeros? It's a lot. It's a lot. There's got to be a better way to signify this because in all honesty, like if you try to count all the zeros there, you might have lost track. I mean, I'm looking at that and it's just all blurring together. So there is a better way to do it, and it's called scientific notation. It's where a number is written as the product of two numbers, meaning, you've probably seen this before, remember that a product is multiplication, timesing, okay? So what we do is we take the first number, multiply it by a factor of 10, and the exponent there represents how many zeros there are then. So the easier way of writing this number is 7 times 10 to the 30th. Yeah, there's 30 zeros there. That's nuts, isn't it? Why would we have to do this? Well, the truth is if you think about it in chemistry, we've been talking about atoms. Atoms are incredibly tiny. And if we want to talk about the number of atoms in an amount of anything that is reasonable to talk about, for example, like the number of atoms there are in just this small little flash drive, it's going to be a number that big. And we can't keep writing numbers like that. So we have to have a better way to represent it. So we represent them in terms of scientific notation. What about really small numbers? What do I mean? Like written really small? No, I mean big decimals like that. That is a really tiny number when you think about it. It's 0.000, a lot of zeros, 7. Can we do that? Well, yeah, we can do the same thing. 7 times 10 to the negative 30th. Why negative 30? Because that decimal has to move 30 places, but we'll talk about that. Why would we have to write numbers like that in chemistry? Again, atoms. Atoms are really, really, really small. If we want to talk about their mass, their radius, because we've talked about atomic radius before, when we get those measurements, they're going to be really, really, really small. And the best way to represent them is in scientific notation. One thing I want to point out that confuses people, these representative numbers here, like the 7 times 10 to the 30th, this isn't a problem to solve. It's simply telling you that's what the number is, and it's a better way of writing it. Okay, same here. These aren't mathematical problems. It's representing this number here, this really, really, really long, big decimal here, as something easier. Okay? So how do we do it? How do we convert to scientific notation? Well, when it comes to big numbers, and again, this is something like really, really long like this. So we've got 7.50000000000, and there's our decimal place. Because remember, even if you don't see a decimal, you know it's at the end of a number like that. What you're going to do is you're going to move the decimal to the left until there is only one number to the left of it. So what does I mean? What does that mean? Well, follow my pointer here. Our decimal's here. We're going to move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to stop here because I want to stop with one number to the left of that decimal. So that decimal is going to go right there like that. Count the number of places the decimal moved. Well, again, we did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All non-zero digits are considered coefficients, and 10 is the number of spaces we move. This becomes our exponent. So what does this all mean? Basically, all of these zeros here are going to get dropped. We don't need them. We move 10 spaces. This is going to be our exponent. So just like in the examples where it was a number times 10 to some exponent, you're going to rewrite it that way. Well, what are you going to write? Well, you're going to write the first part of the number before all those zeros. So 7.5 times 10 to what power? 10. Because you moved that decimal 10 spaces. Okay? We dropped off all those zeros. Now keep in mind, you're only dropping off the long chain of zeros there. If there was a 0 between the 7 and the 5, you'd have to keep that. It's the long chain of zeros that get dropped off. Okay? So let's take a look at some examples. Convert these to scientific notation. So you've got 34 and 75,600. If you'd like to take a minute and see if you can do it on your own, go ahead, pause the video, see if you can do it, and then hit play and I'll go over the answers. If you're sitting here and you have no idea what's going on, I'm going to go through it right now, okay? So, 34. First of all, we need our decimal. We know it's at the end of a number like this, and we're going to move it to the left until there's only one number to the left of it. So let's do that. 1. We moved it one space. Okay, keep that in mind. Moved 1. So we've moved that. We're going to put times 10 after it, and then exponent for the number of spaces it moved, and it moved 1. And that's it. Now, we didn't have to get rid of anything there, did we? No. We did not have to get rid of anything. So our next number is 75,600. Decimals at the end. We're going to move it 1, 2, 3, 4 spots till it's to the left there, and it stops between those two numbers. Okay? Times 10. We moved it 4 spots, but don't forget, these two zeros here, we can drop them off at the end of the number. We don't need them. So if you rewrite it correctly, it ends up being 7.56 times 10 to the 4th. That is our correct answer. Okay? All you do is you move your decimal from the end all the way to the left, stop before the first number here, get rid of all your zeros, the long chain of zeros, times 10, and then the number of spaces you moved is your exponent. So still converting to scientific numbers, let's talk about, converting to scientific notation. Let's talk about small numbers. So this is really, really long decimals that represent really, really small quantities. You're going to do basically the same thing. We're going to move the decimal to the right until there is one non-zero to the left of it. So what that means is we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to stop there. Because once I get past the first digit that's not a 0, I'm going to stop there. So I move 10 spaces. Keep that in mind, okay? Right there is where I stopped. How many spots did you move? You moved 10. That's going to become our exponent again. But when you move from the left to the right, the exponent becomes negative. This is representing the fact that you moved the decimal in a different way. This is representing a small number. So we're going to get rid of all those zeros in the front there because we don't need all those. It's going to become 7.5 times 10. We move 10 spots, so our exponent's 10, but because we went from the left to the right, it's negative. And that's the difference. It's still the same general idea, but you're getting negative exponents this time, okay? So let's take a look at some examples. Convert the following to scientific notation. You got 0.0081 and 0.04578, okay? If you'd like to take a minute and try and do it on your own, go ahead, pause the video, see what you get. If you'd like to see me do it, just keep going. So let's try this out. So our first one here, 0.0081. We've got to move that decimal. So we're going to move it 1, 2, 3 spots. Once we get past the first non-zero digit, we're going to stop. We move 3 places. We're going to get rid of these zeros here. So we have 8.1 times 10 to the negative third because we move 3 spaces to the right. Our next one, 0.04578. So remove that decimal. 1, 2 spots. Once we get past the 4, we're done. Okay. You're going to get rid of that 0 in the front. We don't need it anymore. So we're going to have 4.578. Put times 10 after it. How many spaces do we move? We move 2 spaces. So 4.578 times 10 to the negative second. Guys, that is it for scientific notation, at least in terms of converting numbers and understanding what it is. It is just a way to represent really, really big numbers and really, really small numbers. And it's going to come into play in next chapter really, really heavily. So make sure to try that assignment that is up there. If you have any questions, comment on the Google Classroom, send me an email, however you'd like. I am here to help. If you have any other questions, please feel free to let me know. But otherwise, I hope you all have a great weekend, and I'll catch you on Monday.